Hey everyone, welcome to the CyberNetters System Administration course. I'm Andrew Yek, and in today's video, we will be diving into the fundamentals of Active Directory, one of the core components in managing IT infrastructure in most organizations. Now, if you have already watched our directory services video, this will be a continuation of that concept, where we will build on what you have learned about directory systems and expand into Active Directory specific roles and functions. By the end of this video, you have a more solid understanding of Active Directory, how it works, and why it's crucial for system administration. So, let's get started. First, we will talk about workgroup and domain, the basic building blocks for organizing networked computers. Then we will dive into Active Directory Domain Services, ADDS, which is the heart of the Active Directory. We will also cover sites and replication, explaining how Active Directory ensures data consistency across different locations. Next, we'll explore the objects in the Active Directory and how they represent everything from users to computers in your network. We'll also take a look at the schema, which defines the structure of the data stored in the Active Directory. One of the most important concepts is group policy, which controls how the environment behaves for users and computers. We'll discuss organizational units, OUs, and how they help manage groups of objects in Active Directory. The default domain policy will be explained, as it impacts your entire domain. We will also explore the concept of Active Directory forest and its relationship with domains. Next, we'll break down the global catalog, which makes searching for objects in Active Directory more efficient. Trust and trust relationships are key to understanding how domains interact with each other. Finally, we will wrap up with trees, which define the structure of multiple domains within a forest. Active Directory is Microsoft's system for organizing and managing network objects like users, groups, computers, and printers. It acts as a central hub to store, update, and authenticate all the information about devices on the network. When you log in or need access to resources, Active Directory makes sure you who you say you are. And to find things like printers or contacts is all stored here. Just remember, Active Directory relies on DNS to make sure everything connects smoothly. A workgroup is a simple setup when there's no central control. Each computer is like its own island, so there's no communication between them about users. For example, if you're Andrew on computer 1, you're a completely separate Andrew on computer 2. They don't talk to each other. Managing passwords, you have to update them individually on each computer where you have an account. So, not the best for big networks, but fine for smaller ones. A domain is a big improvement over a workgroup. Unlike workgroups, where each computer is independent, a domain is a collection of computers that share the same Active Directory database. For example, you create Andrew once in the central Active Directory and then connect all your computers into the domain. Now, when Andrew logs in from any computer in the domain, everything syncs up. One of the best parts, password management is a breeze. The admin only has to update Andrew's password once in the domain, and all of the connected computers automatically recognize the change. No more updating passwords individually on each machine. Now, let's talk about Active Directory Domain Services, or ADDS. This is where all the important Active Directory data is stored, things like users, groups, and computers. To keep things redundant and reliable, businesses typically set up at least two domain controllers. Each one holds a copy of the AD database, so if one fails, the other one can step in and keep things running smoothly. And the best part, setting up ADDS is easy with a simple wizard that walks through the installation, like the one you see in Figure 1. Let's dive into sites and replication. Sites represent the physical layout of your network, like branch offices or different buildings. They're made up of well-connected subnets and an Active Directory. They help decide whether a server a client should authenticate against. So a user in one site will connect to the closest server for faster login. Replication keeps everything in sync across domain controllers. For example, if you create a user, like Andrew, on one domain controller, that change gets copied to all the others. Within the same site, replication happens every 15 seconds. Across sites, it happens between 15 to 180 minutes. You can manage all this through the AD Sites and Services tool to make sure that your network stays up to date and runs smoothly. Next, let's talk about objectives and the schema in the Active Directory. In Active Directory, objects are everything that's stored and managed. Users, computers, groups, printers, and more. Each object has attributes, like a user's name, email, or phone number. The schema is like the blueprint for these objects. It defines what attributes each object can have and how they're stored. For example, the schema would define what a user object must have a name, password, or maybe even a department. Think of it as a set of rules for creating and managing objects in Active Directory. Let's talk about group policy, a superpower for centralizing settings across your network. With group policy, you can configure settings for users and computers all in one place. Here's how it works. You create a group policy object, or a GPO, configure the settings that you want, like enabling remote desktop, and then link the GPO to an organizational unit, OU. That setting automatically applies to all users or computers in that OU. No need to configure each device manually. Group policies can also be linked to sites, domains, or OUs, giving you tons of flexibility. And then when you set up your first domain controller, Active Directory gives you two default policies: the default domain policy and the default domain controllers policy. These ensure that your basic security and settings are in place from the start. Let's talk about organizational units, or OUs, one of the easiest ways to stay organized in Active Directories. Think of OUs as folders where you group related users, computers, or other objects. But they're more than just for show. They're incredibly useful for managing policies and permissions. Here's why OUs are a game changer. You can link GPOs to an OU to apply specific settings to everyone inside it. You can delegate control, allowing someone to manage just one OU without giving them full admin rights. For example, imagine you create an OU called users, place Joe in it, and link a GPO to automatically map Joe's network drives. That's it. No manual setup needed for each computer or user. OUs make managing Active Directory efficient, scalable, and secure. Let's talk about the forest in Active Directory. No, not the one with trees. This kind of forest is the foundation of Active Directory itself. A forest is a single instance of Active Directory. It can include one or more domains, all of which share the same schema. Basically, the database definitions for objects like users and computers. The smallest possible forest, it's just one domain controller. But in larger organizations, forests can span multiple domains, making it easier to manage separate parts of the network while keeping them connected. Oh, and here's one important role. A forest is also a secure boundary. Everything inside the forest is protected and managed together, but is separate from the outer forest. Let's start by visualizing how a forest domain and OUs come together in an Active Directory. So, here's our domain. It's the CyberNetters forest, which is represented by this box right here, which represents our entire AD instance. Within this forest, we have multiple domains to manage different parts of the organizations. So the first domain is cybernetters.net, which is the root domain and the foundation of the forest, which is right here. And then the second one is help.cybernetters.net, which is a subdomain for a support team. And then we have teach.cybernetters.net, which is another domain for a training team. So each of these domains are part of the same forest and it shares the same schema. So within these like domains, we have OUs inside these domains to keep things organized. So for example, we might have OUs like IT, support, and admins. And then in help.cybernetters.net, we can have OUs like admins or support staff. And then in teach.cybernetters.net, we can have like instructors and students or something like that. OUs make it easy to apply policies and manage permissions separately for each group. Now that we have mapped out our forest domains and OUs, we can talk about transitive trusts and how they work. So imagine, let's say we have a new domain, or like we obtained a new domain, and it's called netcybers.net. Okay, and then instead of setting up complex individual trust relationships with each domain like cybernetters.net, help.cybernetters.net, and teach.cybernetters.net, we can create a transitive trust, which is denoted right here. So this is basically what it is. A transitive trust creates an automatic chain of trust. So basically, once net.cybernetters.net is connected to the cybernetters forest, which is right here, it can trust all the other domains in the forest, and they trust it back. This makes it super easy to share resources across the entire network without any extra setup for each domain. Let's talk about the FSMO roles. These are the key responsibilities assigned to specific domain controllers, DCs, in Active Directory to ensure everything runs smoothly across your forest and domains. So here's a quick breakdown of the five FSMO roles. So the first one is the Schema Master. It is the only DC in the entire forest that can make changes to the Active Directory schema. So any updates to the schema, like adding new attributes, classes, are handled here. The Domain Naming Master controls the domain namespace. This role is the only one that can add or remove domains from the forest. Plus, it has to be a global catalog server, ensuring efficient handling of domain queries. The PDC emulator ensures backward compatibility with older NT domain controllers. It also manages password replication, ensuring that changes are quickly reflected throughout the domain. The RID master manages the creation of unique security IDs or SIDs for objects in the domain. It oversees the last 32 bits of the SID, which makes sure there's no duplicates. The infrastructure master handles references to objects in other domains. It makes sure that any cross-domain references stay accurate and is up to date. Each of these roles plays a vital part in maintaining the integrity of your AD. We'll discuss these roles in more details in the upcoming Enterprise AD video. In a multi-domain forest, you need at least one global catalog server (GC) on a domain controller (DC). The global catalog contains a list of all objects in the Active Directory, speeding up searches across the forest. In a single domain forest, it is best to make all DC global catalog servers to ensure full functionality if one fails. For optimal performance, the global catalog should be on a server separate from the PDC emulator, ensuring their responsibilities are balanced. Let's talk about users and groups in AD. Users are created in a specific domain and can authenticate against any domain controller in that domain. The default authentication protocol is Kerberos. Groups allow users to belong to multiple sets, and each group's SID is added to the user's security token at login. These are two types of groups. Security groups, which are used for access controls like ACLs, access control lists. These groups' SIDs are included in the user's token. Distribution groups, which are used for organizational purposes, typically used for things like email distribution and not for access control. Now let's break down the different types of groups in AD. Domain local groups, which are used in their own domain, but can contain members from both universal and domain local groups. Global groups are used within their own domain but can also be used across other domains in the forest. Universal groups are replicated across all domains in the forest and can contain members from any domain. Each group type serves a specific purpose, helping you manage and access an organization effectively. That wraps up our overview of Active Directory basics. We covered everything from domains, OUs, and global catalog servers to FSMO roles and the different types of groups. I hope this gave you a clearer understanding of how Active Directory keeps things organized and running smoothly. If you want to dive deeper to those concepts, be sure to check out our upcoming Enterprise AD video where we explore more advanced topics. Thank you for watching, and as always, stay secure and keep learning with CyberNetters.